For the past few years, the world of space exploration has been all about Mars. But before that, Venus was actually the key planet everyone had their sights set on. At the end of the Cold War, the space race was at its peak between the US and the Soviet Union, and in that competition, significant leaps were made in discoveries, leading to the dramatically different worlds we know today. While the Soviets made a lot of the information about their findings public, it turns out there were details they opted to keep to themselves. Join us as we dig deeper into the shocking discovery on Venus that the Soviets kept hidden and how it could alter the course of space exploration forever. It all started with a little beep from the great beyond. In 1957, the Soviet Union shocked the world by launching Sputnik, the first ever artificial satellite. Suddenly, space exploration became the one thing the great powers wanted to excel at. Both the United States and the Soviet Union were determined to prove their scientific prowess and global dominance. It was a race to the stars, and the stakes were higher than ever. The Soviet Union, in particular, was keen to show off its superior technological know-how, and what better way to do that than to set its sights on Venus? At the time, it was the perfect target, a planet not only close to Earth but also similar in size and composition. Everyone called it Earth's sister planet. The thing is, that was just based on size. Was it really like Earth in any way? Could it really be Earth 2.0? These were questions the whole world was asking, and the Soviets decided they were going to get the answers. But it wasn't going to be an easy feat. Venus was known for its incredibly harsh conditions, scorching hot temperatures, thick clouds of sulfuric acid, and crushing atmospheric pressure that could flatten a human being like a pancake. But the Soviet Union was undeterred. They had a plan, and it involved sending a spacecraft to Venus. It was a bold move, to say the least, but it was the start of the Venera missions. The spacecraft, named Venera 1, was launched in 1961, but unfortunately, it didn't quite make it to Venus. It flew past the planet, missing it by a whopping 62,000 miles. However, the Soviet Union didn't give up. They sent another spacecraft, Venera 2, in 1962, but it also fell short and didn't make it to the planet. They say the third time's a charm, right? The Soviet Union launched Venera 3 in 1965, and this time it actually made it to Venus, sort of. The spacecraft crash-landed on the planet's surface but still managed to transmit data for a few minutes before being destroyed by the intense conditions. From this point on, they knew that if the spacecraft were to actually send back useful information, they needed to step up their game. So, they did some redesigning. The newer probes weighed about 2,000 pounds and carried a detachable pod known as a descent module. The descent module was outfitted with a second set of instruments, such as a barometer, radar altimeter, gas analyzers, and thermometers, allowing them to collect as much data as possible, even if they survived for only a few minutes after landing. Venera 4 was one of those probes. Not only did it make it to the surface, but it also discovered high quantities of carbon dioxide in the atmosphere. This was a significant finding because it helped us understand more about the planet's geology and climate. Carbon dioxide is a greenhouse gas that traps heat in the atmosphere, leading to a warming effect. The high levels of carbon dioxide on Venus contribute to its extremely high surface temperatures, which can reach up to 864 degrees Fahrenheit. Understanding the composition of Venus's atmosphere is crucial in understanding the planet's climate and how it evolved over time. Considering Venus and Earth are so similar, this could potentially give us a glimpse into what might eventually happen to Earth too. But that wasn't all. The probe also found that the planet didn't have a worldwide magnetic field. Earth has a strong magnetic field that protects us from harmful solar winds and radiation. Without this protection, life as we know it would not exist. The absence of a similar magnetic field on Venus suggests the planet may not be capable of supporting life as we know it. This also helps us better understand the formation and evolution of planetary magnetic fields, which is important in understanding the history and potential habitability of other planets in our solar system and beyond. Sadly, after roughly 90 minutes of gathering measurements, Venera 4 gently drifted into Venus's thick atmosphere, where it met its death due to the planet's extreme heat and pressure. Venera 5 and Venera 6 were also successful, sending data for more than 50 minutes when they parachuted into Venus's atmosphere in 1969. These probes demonstrated that Venus is exceedingly improbable to harbor life by assisting scientists in further characterizing the world's atmospheric composition. The hopes of Venus being an Earth alternative were smashed, but even then, there were just more and more questions. So more probes had to be sent to make sense of everything. Subsequent flights, such as Venera 7 and Venera 8, successfully landed on Venus and transmitted data back to Earth. These missions produced important information on the planet's atmosphere and surface conditions, including severe temperatures and pressures. Venera 7 had an ambitious descent module meant to land softly on Venus, complete with substantial defense to withstand the harsh conditions on the surface. Initially, it failed, although it managed to relay essential data for a brief time. The lander registered a surface temperature of over 900 degrees Fahrenheit. Despite the failure of the probe's pressure sensor during descent, researchers were able to estimate a surface pressure of around 92 bars. Venera 8 replicated most of the Venera 7 mission in 1972, but without the lander collapsing on Venus's surface. Venera 8 was equipped with instruments for studying Venus's atmosphere and surface. The spacecraft carried a lander meant to descend through Venus's dense atmosphere and land on the planet's surface. The lander fell smoothly through the atmosphere and settled on the surface, sending data back to Earth for nearly an hour before its batteries died. You can clearly see the progression here. Every time something went wrong, the Soviets learned from it, tweaked the next phase of the mission, and fixed the last problem, even if that meant they would just encounter more problems with future spacecraft. It was constantly going from one to the other. According to the data returned by Venera 8, the air pressure on Venus was around 90 times that of Earth's atmosphere at sea level. The Venera 8 working pressure sensor verified Venus's oppressive atmosphere. Still, it also measured ambient light levels on the surface, indicating that future cameras should be able to record Venusian sights. You see, the Soviet Union wasn't content with just landing on Venus. They wanted to see it up close and personal. That's where Venera 9 through Venera 12 come in. These probes carried cameras capable of directly imaging the planet, giving us our first glimpse of the rugged, rocky alien terrain. The early images were a little rough around the edges, but they still revealed vast expanses of harsh environments, complete with impact craters, steep elevations, and lava-flooded basins. Venera 13 and 14, launched in 1981, were even more advanced than their predecessors. They carried landers outfitted with sophisticated acoustic equipment that could measure the speed of Venusian wind. But the real stars of the show were Venera 15 and 16, which replaced the landers with powerful radar-based imaging equipment capable of mapping Venus from eccentric orbits. They gave us a resolution of around a mile per pixel and detailed photographs of Venus's surface, exposing its geology and conditions. We were finally able to get a true look at Venus, and the information just kept getting better. Sure, many cameras failed on these probes, but a few managed to capture and send back the first photographs from the surface of our solar system's second planet. Despite all their efforts, the Venera probes couldn't find any signs of life on Venus. There are no oceans, no lakes, not even a drop of water on this barren planet. However, their research helped us understand more about the extreme environments of other planets and how they differ from Earth. While that's a little disappointing, there was more information these probes found. The Venera 13 probe captured the sounds of the Venusian wind, making history as the first recording of any sound on a planet other than Earth. But that's not all the Venera 13 was able to accomplish. The lander, designed to operate for only 45 minutes on the surface, exceeded expectations and lasted a whopping 127 minutes. During that time, it captured and sent back stunning color photos of the planet's surface, revealing a harsh and barren landscape unlike anything we've seen before. But that's not all, folks. Venera 13 also did some digging and analyzed a sample of Venus's soil or regolith. This analysis provided us with valuable insights into the planet's composition and geology, including the presence of materials like titanium and iron. It's incredible to think that we were able to learn so much about a planet over 100 million kilometers away from us, and that too, in the 1980s. However, with the detailed findings, it was clear that Venus is a no-go zone for life as we know it. With an atmosphere nearly 100 times thicker than Earth's and scorching surface temperatures, it's safe to say Venus isn't exactly a tropical paradise. Plus, unlike Earth and other planets, Venus rotates backward and doesn't have life or seas of water like our blue planet. Despite this, we're not done with Venus just yet. After all these findings, one significant question still looms: why did the Soviets keep so much information from their probes hidden? Well, you see, not everything they learned was made public. Some of the research results were either classified or simply not disclosed to maintain the upper hand in the space race. They didn't want their rivals to know the details, and in doing so, they created an air of mystery around Venus that added to the intrigue. What else could they have discovered? Even after the Venera missions, Venus continues to be a hot topic for scientists and astronomers today. Recent missions have focused on utilizing advanced technology to further explore the planet. NASA and other organizations have proposed new missions, such as Veritas and Da Vinci Plus, to study Venus's atmosphere, geology, and potential for past habitability. These new missions will aim to answer many of the questions left behind by the Venera missions and shed light on the planet's history. So, even though the Soviet Union had a head start with its Venera probes, the story of Venus is far from over. As technology advances, who knows what more secrets this mysterious planet might hold. In the world of space exploration, it's crucial to learn from the past. The Venera missions taught us valuable lessons about planetary atmospheres, geology, and the potential for life elsewhere. As we continue to venture further into the cosmos, we carry the knowledge gained from these missions, paving the way for future exploration and discovery. In the grand scheme of things, Venus serves as a constant reminder that there are still mysteries to solve and new worlds to explore. The universe is vast, and there's no telling what we might find next. As we set our sights on Mars, Europa, and other celestial bodies, let's not forget the lessons learned from Venus, the beautiful, harsh planet that has captured the imagination of scientists and dreamers alike for generations.